So this video lesson is all about what it means to have negative and zero exponents. In order to talk about it, I want to first go back and look at the quotient of powers property from the basic exponent rules video. Now this property says that if you divide two powers of the same non-zero base, remember it has to be non-zero because you can't divide by zero, you subtract the exponent of the denominator from the numerator. So if we have, as we do down in the bottom left-hand corner, x to the fifth divided by x squared, then that becomes x to the 5 minus 2, or x cubed, and we can show that by saying x to the fifth is really just x multiplied by itself 5 times over x squared. We take away 2 of those x's by canceling out and end up with x to the 5 minus 2 because we cancel 2 of those x's out. So with those things in mind, I want to take a look at what this might mean. 2 cubed divided by 2 to the fifth. So see what you can do with it. Play around a little bit and see what you come up with. Try it both using the quotient of powers property and using the expanding and canceling idea, and see what you come up with. Well, we have two different things that we can look at here. We have the canceling, so let's look at canceling and expanding. We have 3 2's divided by 5 2's. Cancel out 1, 2, 3 sets of them, and we're left with 1 divided by 2 squared, which is something that is not something we're terribly familiar with, but something that shouldn't be too terribly shocking. We'll just have more 2's on the bottom. Now, if we use the quotient of powers property, this means that we're going to take the numerator's power and subtract the denominator's power. And for that, we get 2 to the 3 minus 5 is negative 2. So according to what we did, and they should both be correct if we've done them correct, we have one simplification that says 1 over 2 squared, and the other that says 2 to the negative second power. So somehow, if these are both right, then they must be the same. Let's take a look at another example. And this time we're going to use x's instead of numbers. Go ahead and pause the video again, see what you can do with this one. Again, using both the canceling idea and the quotient of powers property. Well, when we look at the canceling, we have 1, 2, 3 x's over 1, 2, 3, 4, 5, 6, 7 x's, which means we can cancel 1, 2, 3 of these x's away, leaves us with 1 over x to the fourth, because we have more x's in the denominator than we do in the numerator. So we cancel them out. We have 4 left on the bottom and none left on the top, but because it's multiplication, it's not a 0, it's a 1. And if we use the quotient of powers property, we have x to the numerator exponent minus denominator exponent gives us x to the negative fourth. So x to the negative fourth and 1 over x to the fourth, if we've done our cancellations correctly, should be the same thing. And so if we look at this again, where we simplified the fractions, we had 1 over x to the fourth for simplifying fractions, and x to the negative fourth for the quotient of powers property. That should mean that these two ideas are the same, that x to the negative fourth is actually the same as 1 over x to the fourth. And actually, this is the definition of a negative exponent. That is, for any power where the exponent is an integer, so positive whole numbers, negative whole numbers, and zeros, and the base is non-zero, then a negative exponent just flips that power down to the denominator. So 5 to the negative fourth is just the same as 1 over 5 to the fourth. And x to the negative n in algebra, any base that's not 0, and any exponent that's an integer, we'll just take this power as it is and move it to the other half of the fraction. X to the negative n is the same as 1 over x to the n. So let's take a look at that for a second and see what we can do when we simplify these two ideas here. And we'll do these together first. So for the first one, we have x squared divided by x to the fifth. By the quotient of powers property, that's x to the 2 minus 5, or x to the negative third. Now, because our exponent is negative, that means we are going to take this power, x to the third, get rid of the negative sign, and put it in the denominator of a fraction. Because right now we just have x to the negative third, so x to the negative third is 1 over x to the third power, or 1 over x cubed. Now, to simplify for the second one, g to the 6 times g to the negative 10th, first we're going to use the product of powers property, which gives us g to the 6 plus negative 10, or g to the negative fourth. And then we're going to use the idea that a negative exponent means we're going to take what power it would be, g to the fourth, and make it the denominator of that fraction. Because we just have g to the fourth, it's going to flip in the fraction, and g to the negative fourth is 1 over g to the fourth. The key point being the negative sign just flips the location of the power in the fraction. It means it's in the wrong place. So go ahead and pause the video, think about that, and see what you can do about simplifying these four expressions. The top two in quotients, the bottom two having to use perhaps both products and quotients. Pause the video and come back when you're ready to go on. So, for number one, x to the fourth over x to the eighth. This gives us x to the 4 minus 8 is x to the negative fourth, which is the same as 1 over x to the fourth, because a negative fourth in a just regular old expression or in the numerator flips the exponent down, or the power down to the denominator. 2 to the 6 minus 2 to the 6 minus 9. Give me a second to erase that there. 2 to the 6 minus 9 is what we get for number 2. That's 2 to the negative third, which is 1 over 2 cubed. Again, negative exponent flipping the location of the power in the fraction. For number 3, 3 squared x to the fourth over 3 cubed x squared, we end up with 3 to the 2 minus 3 times x to the 4 minus 2. That is 3 to the negative first over times x squared. Now this, as it is, presents an interesting challenge because we have one power that has a negative exponent and one power that has a positive exponent, which means that our x squared is going to stay right where it is in the numerator of the fraction, and the 3, just the 3, is going to flip into the denominator. X squared over 3, or over 3 to the first. And finally, for the one on the bottom right, number 4, we have r to the 4 minus, or r to the 4 plus negative 7, which is r to the negative third, which is 1 over r cubed. So that's the idea behind negative exponents. Now we want to go ahead and look at what if the exponents are the same. Go ahead and pause the video and go through this again as a exercise in simplifying fractions and canceling, and using the quotient of powers property. Well, with two different ways to look at this, we have simplifying fractions. This is d times d times d times d over d times d times d times d. And as you can see, each of our sets of d's can cancel until we have nothing left. But because this is multiplication, when we have nothing left, we actually have a 1 over 1, which is the same as 1. So d to the fourth divided by d to the fourth is 1. And that should make sense because d to the fourth is going to be the same as itself no matter what d is. So any number divided by itself is 1. Now, using the quotient of powers property, we're going to take d to the 4 minus 4, which is d to the 0, because 4 minus 4 is 0. So we have this idea here that somehow, if we did all of our calculations right, d to the 0 should be the same as 1. And notice that using d, this could be any number that we have, not 0 because we're dividing by the number, but this could be any number that we have. Not just a positive number, it could be a negative number, it could be a fraction, it could be a decimal, it could be anything like this. And that is the definition of a zero exponent. For any power where the base a is non-zero, then a to the 0 is 1. So again, a can't be 0 because looking back to that idea of quotient of powers property, we can't divide by 0. But as long as our base isn't 0, anything raised to the 0 power is 1. 3 to the 0 is 1. Negative 4 to the 0 is 1. 1/2 to the 0 is 1. Anything to the 0 is 1. So the last set of problems, go ahead, pause the video. This is going to involve some simplification. You may end up with a 0 exponent. You may end up with a negative exponent. But in any case, simplify these expressions. Give your answer both with the negative exponent if you have it, and as the fraction flipping it down. Pause the video and come back when you are ready to go through them. So for number 1, we have d to the 4 minus 8, g to the 3 minus 2, which is d to the negative 4th g, or g to the first. This negative 4th will flip the d exponent and the d exponent in power only to the denominator and get g over d to the 4th. For number 2, we have m to the n minus 3, n to the 2 minus 2. That becomes m to the negative 1st, n to the 0. N to the 0 becomes 1, and in multiplication, 1 just cancels out, which gives us m to the negative 1st, which is the same as 1 over m. For number 3, a cubed b to the negative 2nd times a to the negative 3rd b to the 5th. We have a to the 3 plus negative 3, b to the negative 2 plus 5, which gives us a to the 0, b cubed, or just b cubed. We don't need to do anything with negative exponents or putting it in the denominator. And finally, for number 4, we have g to the 4 plus negative 4, b to the negative 2 plus 2, which is g to the 0, b to the 0, or 1. Because remember, in multiplication, a 0 power is the same as 1. So if the exponent is 0, for a quick review, as long as the base is not 0, then any number raised to the 0 power is 1. And if you have an exponent that's an integer and the base is non-zero, then a negative integer just means that your power is in the wrong half of the fraction. 5 to the negative 4th is the same as 1 divided by 5 to the 4th. X to the negative n is the same as 1 divided by x to the n.